Hi everyone, welcome to another Kuta worksheet tutorial. I am Mr. West. We're going to do regular polygons using SAS triangle area today. So we've already talked about some of my other videos. When you apply the area equals 1/2 the perimeter times the apothem, okay? Where this is the apothem, this distance right here, that's the apothem. And then we have this as the side, so obviously you'd multiply the side length by the number of sides to get the perimeter, okay? That's the traditional way to find the area of these regular polygons, okay? So all of these are the same thing. You have the perimeter, you have the you have the side, you have the apothem, and it's really pretty simple because you just multiply this side by the number of sides, and then multiply that by the apothem, and then multiply by 1/2, okay? Pretty simple. Where it gets a little tricky is when we get to these ones that are highlighted here, okay? So if we have only a side, well, this one's a regular triangle, so we can actually use side squared, square root of 3/4. That's the formula for a equilateral triangle, ET. No phoning home. That's our equilateral triangle, so we'd put in 10 squared, square root of 3/4, and you could type that in your calculator, or you could leave it in simplest form, which would be 25 square root of 3 units squared, okay? Now, another way to do these problems is to create this apothem, and what's going to happen is you want to find this angle here, okay? And you find that angle by first dividing it up into its central angle. Here's the central angle. It splits it up, okay, number of sides, and that central angle is always 360 divided by the number of sides. Okay, so if we're talking about half of that, 360 divided by 3 sides equals 120. So I know this whole thing is 120. So this part of this triangle is 60. And that's important because you can create a right triangle. I've talked about this in my other videos. I'm just giving you a quick summary on how you do this. And then you can either use trigonometry or special right triangles for this case. Not all of them, you can use special right triangles to find for the apothem here, this distance. What color should I use? Right here. This would be our apothem. And once you have this, you can apply the same formula that you've been doing in the above problems, okay? Same thing if we have the apothem given. If we have the apothem given, what we're going to want to do is we're going to want to create a triangle. We're going to want to find this central angle by doing 360 divided by the number of sides, 6, and that gives us 60. So then if we divide that in 2, which we want to do because we want to create this right triangle using the apothem here. Okay, so here's the right triangle I'm talking about this time, where this is 60 degrees, and we can use trig to find the missing half side, and then we can find the side, and then we can find the perimeter, okay? So that's the method that you got to use if you're given the apothem, okay, or the side length. That's what we got to do. There's no way around it. You got to use trig to solve that. Finding the sides or special right triangles for certain shapes. Special right triangles. Okay? And so it's not too bad. But yesterday in class, I stumbled upon a great shortcut when you're given the radius. I got to thank Francesca. Thank you so much, Francesca, for just intuitively deciding that this is way easier. Really hats off to you for coming up with this. Don't know why I've never seen this before, but there's a better way to do it when you're given the radius. Now, traditionally, when you have the radius, that's called the radius, by the way, because it goes from the center to a vertex. Okay, so that's the radius. That's why it's called the radius. If you drew a circle around it, boom, it's the radius of the circle. Okay, you get it. Now, the shortcut for doing this problem, instead of drawing your apothem, making this 90 degrees, finding this angle, finding the side length, okay, finding the apothem, that's a lot of stuff to find. So instead of that, there's an easier way. Check this out. You're still going to want to find the central angle, okay? And how do you find it? Again, you do 360 divided by the number of sides. In this case, it's 6 sides. So we get 60 for this central angle. Now, we're not going to divide it in half like we did before to find the apothem, right triangle, blah, blah, blah. We're not going to do that. Instead, what we're going to do is we form this triangle here, okay? So this is also radius. That's 14. That's why I drew that there. And see, we have this blue triangle, okay? Now, we don't even care at all about this side of the triangle. We don't care. And the reason is we can use the formula for side angle side triangles. We have a side, 14. We have an angle in between, and then we have another side, 14. That's what that 14 is pointing to. So we have a side angle side formula for a triangle, and that is area equals 1/2 B times C times sine of A, where A is the angle in between, and your B and C are the two sides composing that angle. Okay, in this case, for all these regular polygons, B and C are going to be the same because the radius is the same. So what do we do from here? All we do is we're going to do 1/2 times 14 times 14 times sine 60, okay? And that's going to give us the area of that blue triangle. Let me go ahead and punch this into the calculator. 14 times 14, that gives me 196. I'm going to divide that by 2 times 1/2, and then I'm going to multiply by sine 60. And I can just type this straight across on my TI-84, and I got my area of that triangle equals 84.87. Now I'm keeping it in the hundredth. It tells us to round to the nearest tenth once we're done, but we have one more step. The step is, if that's one triangle, okay, that's the area of only one triangle. That's not what it's asking. It's asking for the area of the whole shape. But if I know there's 6 sides, I know that there's going to be 6 of those same exact triangles. So I simply need to multiply this number by 6 for 6 triangles. Times 6, whoops, not sure what happened there, times 6 sides, and then that's my final answer. So I'm just going to take my calculator and go boop, boop, times 6, and I get area equals 509.2. Okay, and we're going to see how accurate that is. Oh, it doesn't have the answer key here. But I can assure you, this is very accurate. This is unit squared, and there's our answer, 509.2 unit squared. I don't know why I changed color. Unit squared. Let me show you another one. Okay, so let's go to the square this time. Square, okay, usually, again, we would draw this. This time would be a 45, 45, 90 triangle. We'd find the apothem. We'd find this side, yada, yada, yada. Okay, that's fine. We can do it that way. Or we can draw this side right here, make another radius, 15. Find this central angle. That central angle is 90 degrees because it's 360 divided by the number of sides, 90. Okay, 90 degrees. Now, a couple different options. Because it's 90 degrees, this is actually pretty easy. We can just do area, get out of here. Area equals 1/2 base times height because the base and height are perpendicular, 15 times 15. Okay, or we can go area equals 1/2 BC sine of A. In this case, A is 90 degrees. Now, the sine of 90 is 1, so you're going to see that it's the same thing. But now you see why it works. So I would just stick with memorizing this, the sine of A formula for side angle side triangles. Just stick with that, and then it basically takes care of itself even if it's 90 degrees, okay? So we're going to do 15 times 15 times sine of A times 1/2, and we get 112.5 units squared. Now, that's not our answer. Why did I circle that? Don't know. But we need to multiply this by 4 because there's 4 of these triangles. 1, 2, 3, 4. 4 of those triangles in there. So we multiply that by 4, and we get 450 units squared. That's our final answer. That is way faster. I don't care who you are. I'll go to debate with you on this one, but that is way faster than finding the apothem. Let's go to the next one, see how fast it is. This is a triangle, so I know it's 360 divided by 3. That's 120. That's also 22. Area equals 1/2 times BC. I'm just going to go ahead and input it. Quit fooling around, times 22 times sine 120. And don't forget, I need to multiply that by 3, and that's going to equal, okay, let's do this. 22 times 1/2 times sine of 120, and then I'm going to divide that by 3, and I get 69.86. We're going to round that to 69.9 units squared. As simple as that. Let's do one more. Oh, that's a square. Let's do a hexagon. So here we have a hexagon. We're just told the radius is 10 without even drawing it. Because it's a hexagon, we know we're going to do 360 divided by 6 for our central angle. So we're going to have area of a triangle equals 1/2. The radius is 10. 10, 10, that's easy. This is 60. 60 degrees are central angle. It's times sine 60. Let's go ahead and do that. We have 50 times sine 60. That's only one triangle. We have 6 of them left. So we multiply by, or 5 of them left, multiply by 6. You guys understand what I'm saying. We multiply that number by 6, and we get, well, first this was about 43. Okay, that was about 43. So we multiply by 6, and we get it's equal to the area of the hexagon is equal to 259.8 units squared. Simple as that. Hope you guys enjoyed this video. Hope this helps you out with any of these problems. I know your teachers probably are like, haha, this is a tough problem. I gave them the radius. You're going to be able to figure it out now. Thanks to Francesca. Students often know more than the teachers, or they can see things in a different perspective. Just always remember that. You have value. Your perspective has value, and make sure to share it with others so we can all learn together. Thanks for watching. This is Mr. West. I'm out of here.